At the bottom of this document, we summarize the different baselines to get to the final baseline. So, for wood 1, we found a total baseline emission of 4,000 tons of CO2. For non-wood 1, the total baseline emissions were 3,000 tons of CO2. Which gives us a total of 7,000 tons of CO2. Our first seen and eligible planting area is 500 hectares, so we have a baseline of 14 tons of CO2 per hectare. We now go to the last template that is explained here, leakage. In the beginning of this document, we selected which leakage occurs on our project area. In our example case, it was fuel wood used, category A, resettlement, category E, and livestock grazing, category F. Below, we have to justify why other activities did not take place on the project area. For example, charcoal burning does not take place in the project area. Then we are going to enter our leakage parameters. We scroll down to the available tables. There are 3 tables available for the categories A till E and 1 for the category F. Let's start with our fuel wood collection, category A, which we also select in the box. We also select a sub-number as we might have more fuel wood scenarios in our project area. As you might remember, 90% of the fuel wood was collected in the non-eligible area and 10% in the area that later became eligible area. Therefore, we fill in that 10% displacement took place. Under this, we have to justify how we got to this figure, by an estimation or by a survey. If a survey took place, don't forget to write down the name of the survey. You would have to include this survey in your application as an attachment. Therefore, you make a zip file out of it that you later upload with this template. In the next column, we once again have to justify the figures we used that eventually led to the result of 200 tons of CO2 per hectare in our example case. So the 200 tons is filled in at the bottom, and the values which led us there we fill in here. In the next column, we enter the size of the area where this took place, which was, in our case, 10% of the eligible area of 500 hectares. At the bottom of this table, we again fill in the resulting total leakage of this subcategory. We first select the subcategory. Then our total of 10,000 tons of CO2. The category E, resettlement, we fill in a similar way. Only for category F, livestock, an adapted table is available. This table already has a fixed name. We fill in the percentage of displacement that takes place. In our example, 150 of the 300 cows went to another area. Therefore, we have 50% displacement. Then we fill in how much CO2 the area contains where the cows shift to. In our example, it was 20 tons of CO2. Again, the conversion that led to this value has to be justified by literature references. Then we select the remaining amount of cattle and the type of cattle. In our case, 150 cows. Finally, we enter the amount of space that is needed for each of these cows in their new location. The result of this leakage calculation we again put in the cell at the bottom of the table, in our case 6,000 tons of CO2. After having filled in all different leakage that occurs, we fill in the table on the final page of this template to summarize our leakage. So, in our case, it was 10,000 tons of CO2 of the fuel wood collection, 0 tons of CO2 of human resettlement, and 6,000 tons from the shift of livestock grazing. This gives us a total leakage of 16,000 tons. Our eligible and foreseen planting area was 500 hectares. So we have a leakage of 20 tons per hectare. The final step of this VERfutures web tutorial is how to enter this data in the web system. Therefore, we go to the project page we created. How this is done is explained in the web tutorial How to Register Your Project. And this web tutorial also explains how to upload your PDF and zip files which you have created. In this web tutorial, we now focus on how to enter the future CO2 fixation in our different management units. Therefore, we go to the box Management Units to the right. We start here with entering the future CO2 fixation of our different growth models as we calculated in the template Future CO2 Fixation. Just click on Future CO2 Fixation. The name we enter here is the name we entered in our template. In our example, Mixed 1, which had a future CO2 fixation of 490 tons of CO2 per hectare. Press Save. Likewise, you enter the other future CO2 fixation values you calculated. When ready, press Back. Then we enter our baseline emissions. Give it a name that refers to the template in which the calculation on this baseline can be found. The name of our baseline template was Baseline 1, which I thus copy here. Always enter the tons of CO2 per hectare. Next, we enter the leakage that we defined in the templates. Here, the name of the leakage should clearly refer to the name of the template in which its value is described. In our case, 20 tons. When this is finished, and we have already entered our tree species as described in the web tutorial How to Register Your Project, we press the button Add. In this web tutorial, we only focus on the CO2 fixation part of the management unit. We scroll down and simply select the values that we have just entered which belong to this management unit. Then we enter the kilograms of nitrogen per hectare of our fertilizer, which will be automatically deducted. In our project, we did not use fertilizer, nor did we burn biomass for land preparation. If we would have burned biomass, automatically 10% would be added to the baseline emissions. If we then press the button Save, assuming that we already filled in the other details of the management unit, a new box appears to the right. That gives us the calculation of the VERfutures for this particular management unit. Note that at the final line, a buffer of 30% is deducted, so that in the end, 31,800 VERfutures are available for sale on this management unit. Likewise, you enter all other management units of your project. This brings us to the end of the web tutorial VERfutures calculations.